Hello, guys. Welcome to this new series, and I'm very excited to start on these projects. So let's start with today's. Today's project is creating a smart port, and it will allow you to create a plant pot which will self irrigate, and you don't have to manage the watering system. So what we are going to do is create an very simple circuit which will check the moisture content in the soil and accordingly give the signal to an motor which can run and pass the water to the plant pot. So it is very simple, and I am very confident that you can do it given the time and effort. So these are all the basic things that we'll require. Of course, you will need a laptop, the Arduino application, which is the Arduino IDE, and also some simulation parts that we'll see further on. But the basic components include this. So here we have the soil moisture sensor. I hope that you can see it. And there are two output prongs which you have to insert in the soil. And what this do is they are conductors of electricity, and I hope you can see the different markings on them. What these are for is they conduct electricity throughout their length, and I would say the difference in the current with the difference in the moisture in the soil is mapped out in the data to give us the relative content of water in the soil. It is not totally accurate, but for our purpose it is very highly precise, I would say. What it does is it passes current through the soil, and according to the water content present, the current gets to the other prong, and so we can identify the amount of water present in the soil. So yeah, this is a very simple sensor, and you can get it on Amazon. Just type in HW080 sensor, and you'll see similar products. There are two output pins, as you can see, and you can connect this any way you want. As we are already using an OPM IC, I hope you are able to see this, which has two inputs and four outputs. What this does is that it compares the current and converts into digital. Now, if you have been following the electronics, then you would know that op-amp work as a comparator to, I mean, we can modify op-amp to work as a comparator. So what we are doing here is comparing the signal with an reference voltage, which is ground here, I guess. And so what we are doing simply is converting analog into different bits of digital code so that we can very easily map it out. Also, the raw data cannot be easily processed by the Arduino board, so such an IC is required to make it more, I would say, motion compatible. The name of this IC is HW103, and you get four output pins here, two of which are VCC and ground, and two give you one of them gives you digital output, and one of them gives you analog output, which you can use according to your applications. Next, we'll need an Arduino Uno board or any other Arduino board which supports digital pin connections and can process this simple data. I think that any Arduino board can work for such applications, and there is no such specifications required. Next, we'll need connecting wires. Some may call these jumper wires. These are used to connect Arduino to different applications, and you can just simply insert them into any of the pins that these sensors and Arduino boards have, like this, and so very easily you can connect without the hassle of electric wires. This can be found in three variations: female to female, male to female, and male to male. And I would suggest you buy all single of those, about 20 pieces each, just so that you can easily manage different applications without having to remove them from your previous projects. So what I would say about the duration of this project, I feel that the simulation part will take about 10-15 minutes, and the hardware part might take about an hour. But by the end of the day, you will have an functioning self-watering water pot which you can install in your house, and just flex in front of your friends, or maybe show your digital prowess. So yeah, it is a very good application, and it is very easy, and believe me, everyone can do it. So now let's see the simulation part, and after that, let's try with the hardware. I hope that you'll have fun, and I think that this is a very good start for our series, and you will know how fun it is to work with sensors, and how very easy it is to implement electronics in day-to-day life.